All right, here we go. Part 2 for our review for the final exam for our College Algebra Corequisite course. Number 16, they want us to factor completely. In this problem, we have 4 terms, and 4 terms indicates factor by grouping. So we're going to group these terms 2 at a time. In the first group, I can factor out x squared. And if I factor out an x squared, that will leave me with x plus 4. In the second group, I can factor out -2. If I factor out a -2, that's going to leave me with x plus 4. Remember, when you factor out, you're dividing, and a negative divided by a negative makes a positive. Now we're going to look at these two pieces. Notice that the stuff in the parentheses does match, and that means that we can factor out the x plus 4. So if I factor out the x plus 4 from each term, that will leave me x squared minus 2, and this is now factored completely. Number 17, we have a trinomial with a lead coefficient, and that's going to indicate the 3R method. So we're going to take the 15 and remove it. And when we remove it, we have to take it to the back and multiply. And so I'm going to need to know what is 15 times 8. 120. And by removing the 15, I have now turned this into a standard trinomial, which is a lot easier to factor. I can read the signs. They're both going to be positive. I'm going to have a y and a y. And then the two numbers I need have to multiply to make 120 and add to make 22. And I'm thinking that's going to be 10 and 12. Check. 10 times 12 is 120. 10 plus 12 is 22. And so now that I have my numbers, remember we're doing the 3R method. So here I removed the 15. Now that it's factored, I need to replace the 15. So we're going to put the 15 back in front of each y. And the third R is reduce. So in the first set of parentheses, I can reduce by 5. In the second set of parentheses, I can reduce by 3. And that's going to give me a final answer of 3y plus 2 and 5y plus 4. Now remember, if you're not sure whether this is factored correctly or not, you can FOIL to check. You can FOIL this and make sure it gives you your problem back. Next, number 18. We need to simplify completely. And to reduce a rational expression, you need to factor and cancel. In the numerator, I have the difference of two squares. The signs are always different in the difference of two squares. R and R make R squared. 3 times 3 is 9. In the denominator, I have a common factor of 6 that I can factor out. And that will leave me R plus 3. 6 times 3 is 18. Now I'm going to reduce the fraction, and I can cancel common factors. The final answer, R minus 3 over 6, is done. Number 19, perform the indicated operation and simplify. Here the operation is addition, and in order to add fractions, I need a common denominator. So we can see that the 2 is going to need to be multiplied by 3 to make the second denominator equivalent to 6. And we can see that the first denominator is going to need an x so that he becomes x cubed. Now remember, whatever you do to the bottom, you have to do to the top. Okay, so I'm going to show it like this. The first denominator needs an x, so I give it to the top. The second denominator needs to be multiplied by 3, and so I do it to the top. Now look what I've got up top. I've got 8x plus 3 all over the common denominator of 6x cubed. And that is done. Next, solve the equation. If you're going to solve a rational equation, your ultimate goal is to get rid of the fractions. So we're going to factor the third denominator. Y squared minus 9 is the difference of two squares. Factors as y plus 3 and y minus 3. And now we can see what the other two denominators need so that all the denominators are the same. We're going to need a common denominator. So the first denominator needs the y minus 3. If I give it to the bottom, I have to give it to the top. And the middle denominator is going to need the y plus 3. Again, if I give it to the bottom, I have to give it to the top. Notice the last denominator has both the y plus 3 and the y minus 3. And so he doesn't need anything. Okay, now if you see what I've done, I now have the same denominator all the way across. Y plus 3, y minus 3. And at this point, I can cancel the denominators. So the numerator is going to be 7 times y minus 3. Notice I have a minus here, so that's minus 9 times y plus 3 equals 8. And since the denominators all canceled, I don't have any fraction. Next step, to distribute. That's going to give me 7y minus 21 minus 9y minus 27 equals 8. Combine like terms. I've got 7 minus 9, which is negative 2y. Negative 21 and a negative 27 is a negative 48. Bringing the negative 48 to the other side makes it positive. And what is 48 and 8? 56. And last but not least, we need to divide by negative 2 to get the y by itself. So my final answer is y equals negative 28. So that's number 20 done. Number 21, the indicated operation is multiplication. Remember to multiply radicals. They have to have the same index. Here, these are both square roots, so they do both have an index of 2. And that means that I can go ahead and multiply these radicals together. So we're going to multiply the radicands. We're going to multiply the stuff under the radical, and that will give me one single square root. Okay, so here we go. 15 times 5, that is 75. X to the 1 plus 1 is 2. Y to the 5 and 4 is 9. So we now have the square root of 75x squared y to the 9. And now we need to try to simplify the radical as much as possible. Notice it does say simplify completely. All right, so what I notice is that 75 is the same as 25 times 3, and 25 can square root. So we're going to take the 75 and break it down into 25 times 3. And then we can take the square root of 25, which is 5, and the 3 is going to be left under the square root since he can't square root. We can take the square root of x squared. Remember, to simplify variables, you have to divide the exponent by the index. So 2 divided by 2 is 1, means I can bring out 1x. And what is 9 divided by 2? How many times does 2 go into 9? Well, it goes 4 times, but it doesn't go evenly. 2 times 4 is 8, plus 1 is 9, and now that is simplified completely. Number 22, perform the indicated operation and simplify completely. All right, so here the indicated operation is subtraction. In order to subtract radicals, they have to have the same index and the same radicand. So I'm going to need to do a little bit of work to get these radicands to match so that I can combine like terms, okay? So here we go. First step, I've got 10, fourth root, and then 16. I know that is 2 times 2 times 2 times 2. 4 2's make a 16 when I multiply. And that's nice because notice the index is 4. That says I need 4 of a kind to bring one out. And for the x to the 7th, I can rewrite that as x to the 4th times x to the 3rd. And remember, I can do that because when you multiply letters, you add their powers. 4 plus 3 is 7. And by writing this as x to the 4th, that's going to allow me to bring those x's out from under the radical. Now, for the other radical, I've got minus 5x, fourth root of, and I happen to know that 81 is 3 times 3 times 3 times 3. 4 3's multiplied make 81. Again, that's nice because I'll be able to bring the 3's out. X to the 3rd, since this exponent is smaller than the index, I'm not going to be able to simplify the x to the 3rd. So he's going to have to stay under the radical. And now let's bring out some stuff, okay? The 2's and the x to the 4th can come out. And that's going to give me 10. Remember, all of these 2's come out as 1, 2. So that'll be times 2. And the exponent divided by the index, 4 divided by 4 is 1, which means I can bring out only 1x. And I'm going to have left the fourth root of x to the 3rd. For the second radical, for the second term, I've got the 5x already out there, minus 5x. The 3's can come out, but remember it takes 4 of them to bring 1 out. So only 1 3 comes out. And left over, I've got the fourth root of x to the 3rd. And then if I multiply, that's going to give me 20x, fourth root of x to the 3rd, minus 15x, fourth root of x to the 3rd. And now I want you to notice that both of these terms have an x, fourth root of x to the 3rd. They both have the same, you could say, variable stuff. And so now these are like terms. I can combine them. Okay, I've got 20 of these minus 15 of these. 20 minus 15, that is 5x, fourth root of x to the 3rd. And that is my final answer, simplified completely. Number 23, rationalize the denominator. Since I have a monomial in the denominator, to rationalize, I simply multiply the top and bottom by the square root of 14, and that's going to give me 7 square root of 22 times 14. Remember, if you have the same index, which these are both square roots, you can multiply the radicals together by multiplying the stuff underneath. So that puts that into a single square root, 14 times 22, over the square root of 14 times 14. Again, those both go under the same square root. And remember that an index of 2 says that you need 2 of a kind to bring something out. So the square root of 14 times 14 is just 14. And the square root of 22 times 14, I need to know what that is. 22 times 14 is 308. And now notice that the 7 and the 14 can reduce. 7 goes into 14 2 times. That's going to be square root of 308 over 2. And that would be the final answer unless the 308 can break down further. So what I want to know is, are there two numbers that multiply to make 308, one of which is a perfect square? And to do that, we're going to play around with the calculator a little bit. And I'm going to start off with the smallest perfect square that I can think of, which is 4. So 308 divided by 4 is 77. And that tells me that 308 can be written as 4 times 77. And then I can separate each one of those into its own square root. And I can take the square root of 4, which is 2. Do you see that? The 4 gets to come out, but I have to square root it. And then these 2's can cancel and gives me the square root of 77. That should be the final answer in simplest radical form. You will need to show this work, but you can use the calculator to check. If you have this particular calculator, you can type in the problem just the way it looks. 7 square root of 22 over square root of 14, and it should simplify completely in simplest radical form. So it is possible to use the calculator to get the answer, but you will need to show your work to get credit. Number 24, solve the following equation. Here we have a radical equation, and the first step to solve a radical equation is to isolate the radical. So the minus 3 is going to have to come over. Once I get the radical isolated, then I can raise both sides to the index power. Whatever the index is, I'm going to raise both sides to that power. And I know that a square root has an index of 2. So I'm going to square both sides, and a square root will cancel. 2x minus 3 equals 9 is the resulting equation. And then 2 more steps and I'm done. Bringing the minus 3 over makes it a plus, which gives me 2x equals 12, and divide both sides by 2, x is 6. And again, you can plug that back into the original equation and check it. 25, perform the indicated operation, which is subtraction, which means that this negative needs to distribute. The stuff in the first set of parentheses just comes down. And then we're going to have minus 6 plus 3i. And then we need to combine like terms. Notice it does say to write your answer in standard form, and that means that the I has to go last. So the real parts, the -8 and the -6, if I combine those, I get -14. And the imaginary parts, 16 and 3 is 19. I. And that is the complex number in standard form. 26. Perform the indicated operation. Here we have a complex number squared. Remember, to square anything means to multiply by itself. And this is going to indicate the FOIL method. So let's F it up. Let's FOIL it. 8 times 8, 64. On the outside, 5 times 8, that's a plus 40i. Make sure you get the I in there. On the inside, we have another plus 40i. And last but not least, we're going to have a plus 25. I times I gives me I squared. And that should raise a red flag for you, because we know that I squared is -1 and is going to need to be evaluated. All right, so what is that going to give me? That's going to give me 64 plus 80i plus 25 times -1, doing the substitution for I squared. And 25 times -1 is -25, which can then combine with the 64. So the final answer is whatever 64 minus 25 is. 64 minus 25, that's 39. 39 plus 80i. And I would like to show you that you can use the Casio to check, okay? We're going to need to go to the menu, and number 2, notice, is complex mode. Now we can input this problem just the way it looks on the test. We have 8 plus 5i. The ENG gives us the I now that we're in complex mode. And the squared and equals. Notice it's going to give us the simplified complex number in standard form. And that's done. Number 27. Solve the equation. This equation is quadratic, which means I need to set it equal to 0. And so the first step is to bring the 63x over. 9x squared, that's going to become minus 63x equals 0. And I can solve by factoring. So what do we have in common? They have a 9x in common that I can factor out, and that will leave me with x minus 7. Now that it's factored, I can set each factor equal to 0 and solve. So for the first factor, I need to divide by 9 to get x by itself. And 0 divided by 9 is 0. 0 is one of the answers. For the other factor, I need to move the -7 over, which makes it a positive. And that is my second solution. And that is done. Number 28, solve the equation. Notice it does say to give the exact solutions, reduce to lowest terms. Again, this is a quadratic equation because it has an x squared, so I need to set it equal to 0. Moving the 1 over is going to make it -1. And now this is in standard form. I can see that A is 3, B is -7, and C is -1. And we're going to use the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And since I know a, b, and c, this becomes a plug-and-play problem. Here we go, negative b. Did you notice that b is already negative? So a negative and a negative is going to make that a positive 7 plus or minus the square root of negative 7 squared makes that a plus 49 minus 4 times a times c all over 2 times a, and then we need to simplify. All right, so I want to know what is the radicand, and the calculator is a nice tool to calculate that stuff under the square root. And if you don't know that the 49 is there, you could actually do it this way. You could say b squared minus 4ac. You can actually type it in. Just remember that negative numbers have to go in parentheses, and that is your b squared minus 4ac works out to be 61, which does not square root nicely. And so this is going to be the exact solutions. If you need to write them separated, that would be 7 plus square root of 61 over 6 and 7 minus square root of 61 over 6. So either way is fine. You can write it with the plus or minus, or you can put it in as separate answers separated with a comma. And now for the last problem on the review for the final exam, and it's got a lot of parts. So we have a quadratic function here. This is our quadratic function. And we're going to have to answer some questions. Part A, does the parabola open up or down? Well, this one opens up. And how do I know that? It's because A is greater than 0. The value for A is 1. 1 is greater than 0, and that's why it opens up. Did you catch that? If the coefficient of x squared is greater than 0, then the parabola opens up. Part B, does the parabola have a minimum or a maximum? Well, if it opens up, then it's going to have a lowest point, which is the vertex, which means that it's going to have a minimum. Guess what? If it opened down, it would have a maximum. So that's how you can tell whether it has a minimum or a maximum, is whether it opens up or down. Part C, find the vertex. All right, so the vertex is the ordered pair h comma k, where h is the formula negative b over 2a, and k is f of h. So we're going to have to calculate this fraction based on the values of a and b to get the x coordinate of the vertex, and then we'll take that value and plug it into the function to get the y coordinate of the vertex. Here we go. So h is negative b, b is negative 5, so that's going to make that positive 5 over 2a. 2 times 1 is 2, so h is 5 halves. And so k is going to be f of 5 halves. And the best way to do that is with the calculator. So we're going to have 5 halves squared. Notice what I'm doing is I'm plugging that in for x there, right? F of 5 halves. says to plug 5/2 in for each x. So that's going to be 5/2 squared minus 5 times 5/2 plus 6. And the y-coordinate of the vertex is going to be negative 1/4. And you probably need to show that work. So here we go. The answer for part C, as an ordered pair, is going to be 5/2, comma, negative 1/4. Part D, write the axis of symmetry. Okay, so for a function, a parabola that's a function, the axis of symmetry is always x equal the x-coordinate of the vertex. So if you already have the vertex, then the axis of symmetry is super easy. Just don't forget that you need the x equal part. Part E, find the x and y intercepts and write your answers as ordered pairs. Okay, so let's write this as an equation. We've got 0 equals x squared minus 5x plus 6. If you notice what I did there is I let f of x be 0. Remember, f of x is y. If I let y be 0, I'm going to find the x-intercepts. And I'm going to solve this by factoring. So the signs are both going to be negative. X and x to make x squared. And then I need numbers that multiply to make 6, that add and make 5. And that is 2 and 3. 3 times 2 is 6. 3 plus 2 is 5. If I set each factor equal to 0 and solve, I'm going to find my 2 x-intercepts. Moving the minus 2 over, moving the 3 over gives me x equal 2 and x equal 3. Those are the x-intercepts. Let's write those as ordered pairs, okay? X-intercepts are 2, 0, and 3, 0. Remember that for an x-intercept, the y-coordinate is always 0. And now to find the y-intercept, I need to let x be 0, which means I need to calculate f of 0. And that means I'm going to plug in a 0 in for every x. So that's going to be 0 squared minus 5 times 0 plus 6. And of course, that's going to be 0 and 0 and 6. So the y-intercept would be 0, 6. Right? Because I let x be 0, so the x-coordinate of the y-intercept has to be 0. And there is the y-intercept as an ordered pair. All right, next. Part F. Write the domain and range of the parabola. The domain of any parabola is always all real numbers. And that is the way that you write all real numbers in interval notation. The range, since this parabola opens up, the range is going to be from low to high, and the lowest point is going to be the y-coordinate of the vertex. So this range is going to be everything from negative 1/4. Remember, we use a bracket because that is actually included, to infinity. That is our range in interval notation. It's always going to be from the y-coordinate of the vertex to infinity. If it opens up, And if it opens down, it will be negative infinity up to the y-coordinate of the vertex. Part G, graph the function using the vertex and at least 2 other points on each side of the vertex. All right, so where's my vertex? 5/2, let's rewrite this. The vertex, 5/2 is 2.5 as a decimal, and negative 0.25 is negative 1/4. Now, the reason I write that as decimals, it's a little bit easier to plot decimals on a coordinate system. So we're going to go over to 2.5 and then down 1/4. There's our vertex. Our x-intercepts are at 2 and 3. So that takes care of 1 point on each side. And then I need another point on each side. So to finish out part G here, I'm going to need to make a table and get one more point on each side. So notice 1 would be a good choice for x because that's a little bit farther to the left of the vertex from the first x-intercept. 1, 2, 3, and then 4 would be another good choice because that's a little bit farther to the right of the rightmost x-intercept. And so to get those y values, we need to plug and play. So here we go. We need to find f of 1, which would be 1 squared minus 5 times 1 plus 6, which is going to be 1 minus 5 plus 6. And 1 minus 5 is negative 4 plus 6, which is 2. And then guess what? This is also going to be 2 because those x values are equidistant from the vertex. Did you catch that? If you go equidistance from the vertex, left and right, since the parabola is symmetric, you're going to get the same y value. I'll prove it. So plugging in 4 into each x, and I'm going to use my calculator to make that a little bit easier. 4 squared minus 5 times 4 plus 6, 2, like I predicted. And so then we can plot those points, the ordered pair 1, 2, and 4, 2. And notice I'm going to have a nice parabola. Come in, and something like that. So there's a hand-drawn sketch of the parabola using the vertex, the x-intercepts, and 2 additional points that I had to come up with. And that's it for the review for the final exam. So if you have any questions or comments, please feel free to put those in the comment section below, or you can text me. And thanks for watching.